Okay, so the next LeetCode question is going to be a binary LeetCode question, which is named search 2D matrix. It's a medium, and instead of using a list of organized numbers in ascending order, what we are given is a matrix. So we got, for example, here 1, 3, 5, 7, 10, 11, and so on. As you can see, it is still organized. It is as if we had a list, and the last element in the previous line is less than the next element, than the first element in the next line. So it's the same question. We are given a target and we need to find it inside our matrix. The only limitation or constraint is we have to do it in big O of log m times n, and m here is the length of the matrix, and n is the length of the inner lists. So this is gonna be m and this is gonna be n. I'm gonna start off by writing a normal binary search algorithm. So as usual, we're gonna have left is equal to 0 and right is equal to the len of, I'm gonna consider the matrix right now as if it was a list, but I'm gonna change it later on, -1, and then while left is less than or equal to right. I did or equal to because it is possible that we will have a list that has only one element. So in that case, the left is going to be equal to the right. So I'm going to calculate the mid is equal to left plus right over 2. This allows us to get an integer, the floor of this calculation. So I'm going to write the closing condition or the stopping condition. So if the matrix of the mid is equal to target, in that case, this time instead of returning the index, we only return I, or return if it's true or false. So return true, and in case we don't find the element, we're gonna return false. And I'll update the indexes. So else if, so elif matrix of mid. I'm going to start off with the condition or the case when the element or the target is to the left. So the matrix mid is bigger than or equal to our target. In that case, the mid is to the right of the target, so we'll need to update the right. So we do right equals to mid -1, else matrix of mid, else left equals to mid +1. So this is a normal binary search algorithm. What I'm going to have to do now is apply it to a matrix, to a list of lists. So I can see here that we've got m is equal to matrix length. So it's the size of the outer list, no matter what is inside of the list. It could be tuples or strings or whatever. We're going to look at the size. So here we see that it's 3. This corresponds to what is to the left. So this is going to be the m, and this is going to be the n. So I'm going to call them constants because they're going to be constant. They're not going to change. M is equal to the len of matrix, and n is going to be to the len of first list. Now what we have to do is it's as if we have the left here and the right here. So this is going to become right is going to become m times n. So this is the number of elements -1 because we start off at 0. Now what we want to do is use both indexes. So I'm going to call them I and j instead of mid, and I and j. But mid is still going to be the number as if we had a one organized list. So from the mid, I'm gonna extract the I and the J. So I equals J equals. So this is not gonna be as if we had a curve. So I is not to the top, is not here, but rather to the left. It's with the M and J here. This way I can do matrix of IJ instead of JI. And to extract, for example, if we had this is the mid 16. I mean, if we take the first example, it's going to be 11. So if we want to extract the I and J, we can do the calculations using only N. So we're not going to use M. We can calculate the modulo, and this is going to give us the J, and we can calculate the division by N, and this is going to give us I. So I'm going to do I is to the left, so I is the mid divided, so it's integer divided by the n, and j is the mid divided modulo n. And this should work. Okay, all good.